Hi and Assalamualaikum. In this video, our group will present about what is application of differentiation, which is related rates. Now, I will introduce to our group members. Let's start with Muhammad Faisal Hakim bin Muhammad Zulkifli and Ahmad Fidaus bin Azmi. We both are from group D1C DCS 110 2D. So let's get into the introduction. So what is differentiation? Differentiation is a method of finding the derivative or the rate of change of a function. It is used to determine the maximum and minimum values of particular function. The rate of function is defined as dy over dx equal to fx equal to y. The techniques to solve differentiation problem is derivative of sum and difference, derivatives of product function that is productable, and derivatives of rational functions that is questionable. The applications of differentiation has five parts. There is related rates, analysis of function 1 that is increasing, decreasing, critical point, concavity, and inflection point. Number 3, maximum and minimum problem. And number 4, analysis of function 2, relative extrema, first and second derivative test. And the last one is role theorem and mean value theorem. So what is related rates? Related rates is a problem that involves at least two changing quantities. The rate of change, usually with respect to time. The function of related rates is to compute the rate of change of one quantity in terms of the rate of change of another quantity. It is to be more easily to measure. The steps for solving related rates problem is write an equation that relates the various quantities of the problem and use the chain rule or implicit method to differentiate both sides of the equation with respect to time. For the problem statement 1, a conical water tank filled with water has a radius of up cm at the top of hcm height as shown in figure 1 below. For the question A, if the height of the water is twice the radius, show that V equal to 2 over 3 pi r cubic. For the question B, the water flows out of the tank at a rate of 15 cm cubic second minus 1. How fast is the radius of the surface of the water changing at an instant when the height of the water is 4 cm? The solution for the question A is, since it's been stated that the height of the water is twice the radius, so we put h equal to 2r. And the formula of volume of cone is V equal to 1 over 3 pi r square h. Since we know that the value of h, we can replace it with the value given. So we can write with V equal to 1 over 3 pi r square multiplied with 2r. So the final answer should be V equal to 2 over 3 pi r cubic. So for the question B, this question has stated that the water flows out of the tank at the rate of 15 cm cubic second minus 1. So this indicates that the water volume is decreasing over the time. Therefore, we write dV over dt equal to 15. Since the water in the tank is closed out, so we put the negative at the 15. So that's why it becomes negative 15. Then we write the dV over dt equal to dV over dr multiplied with dr over dt. For the question A, V equal to 2 over 3 pi r cubic. So we can differentiate it into 2 pi r square. So we can replace the dV over dt into negative 15 and the dV over dr into 2 pi r square. So we can write it into negative 15 equal to 2 pi r square multiplied with dr over dt. Since we know that dh equal to 2r, so we move the 2 into the left side. So it became r equal to h over 2. In the negative 15 equal to 2 pi r square multiplied with dr over dt, we can replace the r into h over 2. So we can write it into negative 15 equal to pi h square over 2 multiplied with dr over dt. Since the question has stated that the height of the water is 4 cm, so we replace the height into 4. Then the 2 above the pi 4 square, we can move it into the left side. So the negative 15 will be multiplied with 2. So we write the answer into negative 30 equal to 16 pi multiplied with dr over dt. The 16 pi came from 4 square, and the 16 pi can be removed into the left side, and it will become negative 30 over 16 pi equal to dr over dt. We can simplify the negative 30 over 16 pi. So the final answer will become dr over dt equal to negative 15 over 8 pi.
Problem statement number 2. An ice cube in the shape of a cylinder is melting at a constant rate of 2 centimeters over seconds, as shown in below. Now, for a reference, r means radius and h means height. Just to collect the hint, surface area of a cylinder is 2 pi r square plus 2 pi r h. Volume of a cylinder is pi r square h. Now, the first question wants us to find the surface area of the ice cube in the terms of r. Let's take a look at the how to solve it. Now, first we need to find the formula of area surface for cone, which has already been given in the question, which is 2 pi r square plus 2 pi r h. Now, we already know the value of h, which is r plus 2. So what we need to do is replace the h with the value given. Now, from there, we should just multiply it like we normally do. And for the final answer, we should be able to get 4 pi r squared plus 4 pi r. Now, for question B, it asked us to find the volume of ice cube in terms of r. Like question A, we already have the formula volume for cone, which is pi r squared h. And like the previous question, we already have the value of h, which is r plus 2. And just like question A, we need to replace it. And for the final answer, we should be able to get pi r to the power of 3 plus 2 pi r squared. Now, after we wrote down the formula, we need to replace the known value. We already have the value of dv over dt, which is negative 2. And for dv over dA, we don't have the exact value of it. So what we need to do is we need to expand it even more to the form of dv over dr times dr over dA. Now, surprisingly, we already have these two values. dv over dr, we already have the value, which is 3 pi r squared plus 4 pi r. And dr over dA, we have it, but it's in reverse. So what we need to do is we need to write 1 over 8 pi r plus 4 pi. Now, from there, we need to multiply it normally, and we should get that form. Now, from there, we should multiply it, and we should be able to get this form where 3 pi r squared plus 4 pi r over 8 pi r plus 4 pi. Now, we already have the value of radius, which is 4 centimeters, as is stated in the question previously. So now we already have the value of r, which is 4 centimeters, as it's stated in the question C just now. Now, all we need to do is replace the r with 4. And from there, after we multiply it, we should be able to get the equation negative 2 equals 64 pi over 36 pi times dA over dt. Now, 64 pi over 36 pi, we can simplify it to the form of 16 over 9. From there is a simple algebra where 9 goes to negative 2, where it will be negative 18 equals 16 times dA over dt. And from there, 16 should go to the negative 18 sides, where we oversimplify it, and we will get the value dA over dt, which is negative 9 over 8 centimeters square over second. Now, for conclusion, by using differentiation method in this problem, we can conclude that this application of differentiation can be used to define a value of a volume, solve a problem that related to value of any volume, and find a solution for any other problem. For acknowledgement, at the end of this project, we are very proud of our hard work because we managed to complete it as the time given by our lecturer, Dr. Azwani. We believe that without a cooperation between both of us, this assignment is impossible to be done. Our lecturer also could not be forgotten in this assignment because we are truly, sincerely thank you to our Calculus 1 lecturer, Dr. Hazwani, for teaching us through this semester and for the guidance in completing this assignment. Last but not least, to our family members, thank you for keeping on encouraging us all the time. Now, for the reference, all the question answered was from Calculus 1 workbook as in shown in the picture.